These are nice toys. What we'll do is during your time tomorrow, I'll let you have a chance to improve your grade. Okay, folks. First thing I'm going to do is I'm going to pass back your exam grades. I did get the grading done and get the I did post the new grade with on Blackboard. It significantly helped a lot of people. So I'm happy about that. I hope that you learned something from it, and specifically gathered a better understanding of what you missed on Monday. Because if you didn't, it's not worth what it was. It's not going to help you. So hopefully you figured out what you missed and why you missed it, because you are going to be using some of these concepts again later on in the semester. So again, I'm going to pass it back. I do have one question. I'm also passing back those that attended the conversations with chemists about coffee. I'm passing back the notes, but I had a note that does not have a name on it, and I don't know handwriting. So if it's yours, I believe it was turned in on Monday after the test on Friday. So I think it was turned in then. If it's yours, let me know so that I can get you your points. Okay. Kaylin Aaron. Julie Baruman. Isabella Blair. Ashlyn Bedard. Huh? Oh, I didn't say Isabella Brown. Blair. Caitlin Boyd, February. Nick Reed. Nick. I can't yell loud enough, so y'all are gonna have to be nice. John Burgess. Brittany Hagel. Bailey Cashin. Noel Contreras. Ty Crow. Zoe Davis. Hannah Gatson. Cynthia Gonzalez Omegar. Megan Hall. Mariana Hamilton. Ali Hernandez. Marissa Hartless. Hannah Hicks. Tamaya Hodges.
This is mine.
Okay, put your name on it.
I'm
and
sorry,
I'll
can I
take
use this?
Yes.
Thank
Shamia Holt. Okay. I'll get you your credit that way. Brittany Wynn. Maya January. Joey Larkin. Takia Johnson. Skylar Johnston Robbins. Zoe Lowry. Mallory Marshall. Michaela Morrison. Hadia Mohammed. Danielle Newton. Winnie Wynn. Lily Peters. Hayden Knocker. Gracie Pickens. Nikinla Pickens. Kelby Pye. Hayden Pounds. Nicholas Raman. Janie Reed. Erica Semler. Ashton Tran. Michaela Watson. Avery White. Adam York. I think I have all your grades back to you at this time. When you look at your grade, that the back copy shows you how many points was added to the overall grade, and then the circle grade is going to be the official grade that is now on Blackboard. Again, as a reminder or as a note, anybody that had 135 to 150 made an A. Anybody with 120 to 134 made a B. Anyone with a 105 to a 119 made a C. Anybody with a 90 to a 104 made a D. And anything less than a 90 is an F. So that just lets you know what type of grade it was. Any questions for me? Okay. Then I'm going to go ahead and get started into today's information. On Friday of last week, okay, I'm not talking until everybody else stops. This is the maximum voice I have. On Friday of last week, we talked about the periodic table. The periodic table contains all of the atoms of the elements that we know. Now, what we're going to do is we're going to take those atoms of the elements and we're going to break them down into their subatomic particles. I do expect you to watch the videos, the flipped lecture videos about the atoms of the elements. There is historical perspective in those videos that explain how we discovered the subatomic particles that are associated with the atoms of the elements. The first thing that I want to mention is on Friday, when I talked about hydrogen, for instance, I said it was element number 1 on the periodic table. Because when you look at the periodic table, blue number is number 1. When I talked about, I think somebody gave me element number 35. Element number 35 is bromine. We called it element number 35 because that was the blue number on the periodic table. That number has a name. The name of that number is called its atomic number. The atomic number describes the number of protons in an atom of an element. Every single hydrogen atom has 1 proton. Every single bromine atom has 35 protons. So that atomic number is telling you the number of protons. The atomic number also is telling you the number of electrons in a neutral atom of an element. So, in a neutral atom of hydrogen, it not only has 1 proton, but it has 1 electron. In a neutral atom of bromine, it not only has 35 protons, but it has 35 electrons. So when we say element number 31, and I look at the periodic table, I see gallium. That means that every gallium atom has 31 protons and it has 31 electrons if it is a neutral atom of an element. These are 2 of the 3 subatomic particles. Oops. Oops. Oh, well. So, the subatomic particles are the proton. A proton has a mass in kilograms of 1.67262 times 10 to the minus 27. Think thinking about what that minus 27 means, it means it's really, 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 really tiny. It has essentially hardly any mass whatsoever. It's not something you're going to be able to hold and touch because you're not going to, I mean, technically you are holding and touching it, but you can't feel it because its mass is so small. Now, instead of talking in terms of kilograms, we tend to talk the mass in terms of atomic mass unit. And a proton has an atomic mass unit of 1.0073 AMUs. That number is mentally easier to handle. I personally don't like thinking in terms of scientific notation if I could avoid it. So this is a much easier number to handle mentally. A proton has a +1 charge. And the protons are found within the nucleus of the atom. The electron. The electron has a mass of 0.00091 times 10 to the negative 27 kilograms. Looking at those two numbers, an electron has a much, much smaller mass than does a proton. In terms of atomic mass units, which again is easier mentally to handle, it is 0.00055 atomic mass units. An electron has a -1 charge. I see people looking at my number here, so let me clarify it. Maybe that will help. And it is found in the electron cloud. The third subatomic particle is that of the neutron. The neutron has a mass similar to that of a proton. At about 1.674, it's slightly heavier than a proton. Again, thinking in terms of a unit that's easier to mentally understand, it's 1.0087 AMUs. The word neutron comes from the word neutral. It has no charge. And the neutron is also found in the nucleus. Now, when we think about, let's talk hydrogen. We said hydrogen was element number 1. So it has an atomic number of 1. So we know that it has 1 proton and it has 1 electron. The most common form of hydrogen has 0 neutrons. So if I were to, so what I want to do is illustrate the hydrogen atom. In its nucleus, there would be 1 proton. And then in the electron cloud surrounding the nucleus, it would have 1 electron. Notice that I'm representing the proton with a plus because it has a plus charge. And I'm representing the electron with a negative because it has a negative charge. Let's talk helium. It's element number 2 on the periodic table. So its atomic number equals 2. That means that the number of protons is going to equal 2. And in a neutral atom of an element, the number of electrons is going to equal 2. The most common form of helium has 2 neutrons as well. So looking at the atom of the element, in the nucleus, I would have 2 protons and I would have 2 neutrons, which I'm going to represent with a letter N. That is all going to be in the nucleus of the atom of the element. Then in the electron cloud, it would have 2 electrons. Folks, if you look back at the masses, and let's look at the atomic mass units. Almost all of the mass for the atom of the element is right here. We're talking about 4 plus atomic mass units sitting right here. Whereas we're talking about 0.01 atomic mass units out here. So almost all of the mass of an atom of an element is found in its nucleus. It is for that reason that we have another term called the mass number. The mass number, because almost all of the mass is associated with those protons and neutrons. The mass number equals the number of protons plus the number of neutrons. So for this helium atom right here, it would have a mass number of 2 plus 2, or in other words, 4. Now, before I get into the problem that you can expect to see on the homework, there is one more thing I want to discuss. I have discussed how much a proton weighs in kilograms, and I have discussed how much a proton weighs in atomic mass units. I have discussed the charge of a proton, and I have discussed where it is located. I've done the same thing for an electron and for a neutron. But the last thing I want to just get into, or the next thing I want to get into, is what is the responsibility of each subatomic particle in an atom of an element? For the proton, it determines the identity of the atom of the element. Because every atom of the same element will contain the same number of protons. The electron, as we will discuss later, is responsible for the reactivity of the atom of the element. Basically, folks, when we start getting into the development of compounds, it's going to be the electrons that are going to be responsible for making those compounds. And lastly, the neutron. The neutron is responsible for the isotope of an atom of an element. So, what I want to discuss right now is this concept of an isotope. An isotope is atoms of the same element that have differing numbers of neutrons. Isotopes can be represented using three different representations. The first representation is X, A, Z. Here, X represents the element symbol. A represents the element's mass number. And Z represents the element's atomic number. Now, the element symbol and atomic number are repetitive, because if I say, what is element 77 up there? That's its atomic number. And you go, element 77 is IR. That's its atomic symbol. So that's really a repetitive piece of information. So the second way that it is represented is simply with its symbol and its mass number. And the third way is, I think, done mainly because of typing purposes. You can represent it as its element symbol dash its atomic number. I mean, its mass number. So, hydrogen has 3 isotopes. I gave you its primary isotope previously, and that would be a hydrogen 1. This one is referred to as hydrogen. The second one is called deuterium. And it is H2. And the third one is in the Toby Maguire? No. Anyhow, in one of the Spider-Man movies, tritium. And that is hydrogen 3. From these symbols, you should be able to give me 5 pieces of information. You should be able to give me the mass number, the atomic number, the number of protons, the number of electrons, and the number of neutrons. In our last 7 minutes, that's what we're going to do for these 3 isotopes of hydrogen, and then we will do a lot more of this on Friday. Okay. The very first thing is coming back up to this. What does this symbol mean? This symbol, the X is telling me the element's symbol. And the A is telling me the element's mass number. They mean the same as the one I gave you to begin with. I just didn't write it all out this time. Now I have. But the element symbol is represented by whatever X is. So in this case, it's hydrogen, H. That's the element symbol. In this case, or in these cases, the element is hydrogen. These numbers that are superscript to the left is telling you the mass number. So for our first element, or for hydrogen, regular hydrogen, it has a mass number of 1. Deuterium has a mass number of 2. And tritium has a mass number of 3. The atomic number is based off of the symbol. This is hydrogen according to the symbol. You look at the symbol, you look at your periodic table and find out what its atomic number is. Hydrogen is element number 1 on the periodic table, so its atomic number is 1. That is true for every single one of these. 1, 1, 1. Because they are all hydrogen. If you look back in the notes, the atomic number tells you the number of protons. So if it is atomic number 1, that means it's a 1 proton. That is true for all of our forms of hydrogen. The atomic number also tells you the number of electrons in a neutral atom. So if it has 1 proton, it has to have 1 electron. Now, why was that neutral? What charge does a proton have? It has a +1 charge. What charge does an electron have? -1. So them added together is equal to 0. That's why it's called a neutral atom. Now the neutrons. To get to your neutrons, you have to remember that the mass number equals the number of protons plus the number of neutrons. So for our first one, if the mass number is 1 and our number of protons is 1, that means that the number of neutrons had to be 0. For our second one, if the mass number is 1 and the number of protons, if the mass number is 2 and the number of protons is 1, then the number of neutrons has to be 1. For our third one, if the mass number is 3 and the number of protons is 1, then the number of neutrons has to be equal to 2. And that is how we will take a great big long table, and it won't be quite as, I may give you the symbol, I may give you other information, but from that we're going to discern all of these subatomic particles, the atomic number and the mass number, and we're going to do that on Friday.